Hey everyone, and welcome back to Bioinfo Tips. In today's video, we're diving deep into creating advanced heat maps in Python, an indispensable visualization tool for uncovering patterns in large biomedical data. If you work with gene expression, proteomics, or any data where you need to identify groups of samples or genes with similar profiles, then this tutorial is definitely for you. We're going beyond basic heat maps. We'll be incorporating hierarchical clustering to visually organize your data, and you'll see how Python libraries transform raw data into powerful, interpretable insight. A heat map is a graphical representation of data where values are mapped to colors. In bioinformatics, it's widely used to visualize the magnitude of data, like gene expression, across different samples. What makes a heat map advanced is its ability to integrate hierarchical clustering. Clustering, this is an unsupervised machine learning technique that organizes data into groups, clusters, based on their similarity. Hierarchical clustering, it builds a tree of clusters, a dendrogram, that illustrates the grouping hierarchy. This allows us to see how genes or samples merge into larger or smaller groups. By combining a heat map with dendrograms on both the gene and sample axes, we can recorder the data so that genes with similar expression patterns and samples with similar molecular profiles are placed next to each other. This makes discovering biological patterns much easier. Adding color annotations for sample metadata makes the interpretation even richer. For our tutorial, we'll generate a simulated gene expression dataset. We'll have 20 genes and 12 samples. We'll simulate that the sample come from two groups, control and treated, with 6 samples in each group. We'll also have a metadata data frame for the samples, indicating which group each belongs to. This is crucial for adding those helpful color bars that let us visualize the groups right on the heat map. Time to code. We'll use pandas for data manipulation, NumPy to generate our simulated data, and a powerful duo of Seaborn and Matplotlib to create and customize our heatmap. Once we have our libraries imported, it's time to generate the gene expression and metadata data frames as a simulation. This simulated dataset has patterns that clustering should be able to find. In your actual work, you'd load your real data here. Now let's prepare metadata for color annotation. In this step is key to adding those handy color bars that indicate your experimental groups right on the heat map. Now for the final step, let's create the advanced heat map with clustering and annotations. The SNS.clusterMap function is the star of the show. It automatically transforms clustering and organizes the heat map. Standard scale equals to 0 is crucial for expression data as it normalizes each gene independently, allowing you to see relative expression change. Call underscore colors is where we add our sample metadata annotation, and annote equals false is generally preferred for larger datasets, as annote equals true can clutter the plot with numbers. You can try true if your dataset is very small. The gene and sample names automatically appear along the edges of the dendrograms, providing labels for the hierarchies. And that's it for today. You've learned how to create and interpret advanced heatmaps with hierarchical clustering in Python using Seaborn. This is a powerful and visually impactful technique for any scientist working with complex data. If you found this video helpful, please hit the like button, share it with your colleagues, and subscribe to the Bioinfo Tips channel for more bioinformatics and software tutorials for science. Leave your comments below if you have any question or suggestions for future videos. Thanks for watching and see you next time.